In this video, we will see about series RL circuit. Now, let us analyze a resistive inductive circuit, that is a RL circuit connected across a AC voltage source. The voltage source is given by Vm sin omega t. We will find what is the voltage across resistor as well as voltage across inductor. This is a series circuit. The current through resistor as well as inductor remains the same. That is, only one current will flow in this circuit. So, I and I is the current through both resistance as well as inductance. So, what will be the voltage across the resistor? In a resistive circuit, current and voltage will be in phase. So, VR will also be in phase. Whereas in case of inductor, the current lags the voltage by 90 degree. So, VL will be 90 degree ahead and current is lagging by 90 degree. In case of series circuit, you can take current as reference because current is common in all the parts. So, you can take current as reference and draw the voltage. XL is equal to L omega. And phasor addition V is equal to, that is the total applied voltage is equal to this VR plus VL. So, this is not arithmetic sum, we are adding it phasor. Now, let us draw the voltage triangle. So, this is a series circuit. So, taking current as reference and voltage across the resistor will be in phase with the current. And the inductor voltage will be 90 degree ahead of current, or the current will be lagging the inductor voltage by 90 degree. Now we can find the resultant voltage. So this is the resultant voltage V. So we can write it at V square is equal to VR square plus VL square. So what is VR? I into R. What is VL? I into XL. So we will get I into Z, where Z is the impedance, or you can write it as root of R square plus XL square. Now let us draw the impedance triangle. We know V is equal to I into Z. This impedance Z can be written as R plus J into XL. What is XL? XL is L omega. So in rectangular form we can write R plus J XL. In polar form we can write it as Z, magnitude of Z as well as phase angle. So this is the impedance triangle. R XL will be at 90 degree and the resultant is impedance Z. So how to, if you know R and XL value, you can find Z and phi value. So Z is given by root of R square plus XL square and phi is tan inverse of XL by R. Suppose if you know the polar form, we can convert it into rectangular form. That is cos, what is cos phi? R divided by Z. So cos, you can find R from this if you know Z value. Similarly, you can find XL value from this formula. Next, we will find the power factor. So, what is power factor? It is the cosine of the angle between the voltage and the current. So, find what is cos phi from the impedance triangle, that is given by R divided by Z. So, power factor is equal to R by Z. So, it is an RL circuit. So, inductance is there. So, the current lags the voltage and this is called lagging power factor. Next, we will resolve the current into two components. So, this is I and V is here. I am splitting the I into two parts. One in phase with the voltage, the other will be 90 degree out of phase with voltage. So, this is called active component of the current and this is called reactive component of the current. and the phase difference between V and I is angle phi. So I is equal to, I can write it as IA square plus IR square. So IA is I cos phi and IR is I sin phi. So there are two components, active component IA, which is in phase with the voltage. This is called the active or real component of I. And another component is the reactive component, which will be at 90 degree to the voltage, and this is called reactive or quadrature component. Now we have to draw the power triangle. So there are three types of power: active power, which is represented by letter P, reactive power or quadrature power by Q, and that third one is called the apparent power S. So the active power is given by P is equal to V into IA, that is the in-phase component of the current, product of voltage and in-phase component of the current. So that IA already here derived, it is I cos phi. So VI cos phi. What is cos phi? R by Z. So substitute here. Now what is I? You can write it as V by Z. So it become I square R. So next we have reactive power or quadrature power, which is given by Q is equal to V into quadrature component of the current, that is given by I sin phi. What is sin phi? XL by Z. So if you substitute, you will get I square into XL. Similarly, you have apparent power S, which is given by V into I, or you can write it as I square into Z. Next, we will draw the power triangle from the impedance triangle. So we have seen three types of power: active power, which has a unit of watts; reactive power, which will be measured in reactive volt ampere, or we can write it as var; and apparent power is measured in volt ampere. You take a glass of beer or a coffee, you can see that the actual content will be this much, but after that you will have some foam. So this is the actual quantity. It means that this corresponds to the real power, or the real power will do the useful work. Reactive power is something which is used to energize the reactive components. So this does not do any real work, but you will be paying for the whole quantity. So that is apparent power. So in industries you can see they will pay for the whole apparent power, but only real power can be used to do work. Reactive power will be used to energize the reactive components. So the power triangle can be written as P, Q and S. So S is given by root of P square plus Q square, or you can write P plus J into Q. So the RL circuit waveform, it is very easy. V is Vm sin omega t, I is Im sin omega t minus phi, because inductance is here. So the current will be lagging the voltage, so by an angle phi. So current lags voltage by an angle phi. So the points to remember here are V equal to Vm sin omega t, I equal to Im sin omega t minus phi. So the current lags the voltage by angle phi. And this is the impedance triangle, and Z is equal to, impedance is equal to root of R square plus XL square. And phi is equal to tan inverse of XL by R. So the active power is equal to I square R watts. Reactive power is I square XL into var, that is reactive volt ampere, and apparent power is measured in volt ampere. So this is the power triangle. S is equal to root of P square plus Q square. Let us do some problems to understand the concepts clearly. For a RL circuit, the supply voltage is given and the current is also given. We have to find the value of resistance, reactance and impedance. So what is the given data? Voltage and current is given in rectangular form. What we have to find is, first let us find the impedance. So impedance Z is equal to V by I. So this is division. So it is better to convert it into polar form. If you have calculator, you can directly convert in rectangular form itself. But if you are doing it manually, convert it into polar form. So how to convert this polar form? So V is equal to J10. J represents angle of 90 degree. That is, no real part is here, only imaginary part is there. So that magnitude angle is 90 degree. So for current, let us do the calculation. I is equal to, what is the magnitude? Real part square plus imaginary part square. Then add it, take the square root. So that is equal to 1. How to find the angle? Tan inverse of imaginary part divided by real part. So that will give you the angle. So we got voltage and current in polar form. Now we will find what is Z. So divide it, 10 by 1 is 10, 90 degree minus 36.9 will give you 53.1 degree. So we got the impedance in polar form. So let us convert this polar to rectangular form. So how to convert? So real part will be equal to magnitude of this into cos of this angle. Imaginary part is equal to 10 sine of this angle. So you got 6 and 8. So Z is equal to 6 plus J8 ohms. So we can say the resistance value is 6 ohm and XL value reactance is 8 ohms. So the answer is R, XL and Z. You write it separately. So this is the answer. Now we will take another problem. This is similar to the previous problem except that the voltage and current are given as expression. Okay. Here also we are going to find resistance, impedance as well as reactance. So V is given in this form, I is given in this form. So what is this form? V equal to Vm sin omega t plus some angle. Similarly, current is also given as Im sin omega t plus some angle. Okay. So what is this omega t? So let us take voltage expression. V is equal to 15 sin here 314t, that is omega t. So omega t is equal to 314t. And here angle is given. So let us convert this radians into degrees. So phase angle of the voltage is 5 pi by 6, that is equal to 5 into pi is 180 degree divided by this 6 will give you 150 degree. So the voltage phase angle is 150 degree. Then find the phase angle of the current. So 2 pi by 3. 2 pi by 3 is 120 degree. So here you have 150 degree and here you have 120 degree. So let us draw the waveform. You see the voltage waveform. It starts at 150 degree, that is minus 150 degree, and current starts at minus 120 degree. So we have voltage waveform and current waveform. Here the current is lagging the voltage by an angle of 30 degree. So phi is 30 degree. I lags V by 30 degree. So this is a inductive circuit or RL circuit. So now we will find what is the impedance Z. Z is equal to Vm divided by Im. So this is Vm, this is Im. So 15 divided by 5, that is equal to 3 ohms. So we found the impedance Z. So this is the impedance triangle for an RL circuit. You have R, XL and Z. So from this we can find what is cos phi? R divided by Z. So cos phi is 30 degree. So cos 30 is equal to root 3 by 2, or you can write 0.86 is equal to R by Z. So you know Z, you find what is R. So you got R. Similarly, you can find XL from sin phi equation. So XL, you can find it out. So if you know XL, you can find what is L. XL is L omega. So omega is given as 314. So what is L? You find it out. So this is the For the previous problem, let us find what is the active power, reactive power and apparent power. So V and I given, we have found these values R, XL and Z. So let us find what is the active power P is given by I square R. So I square. What is this I square? Always remember, when you are calculating power, it should be RMS value. This current value should be a RMS value. What is IRMS? For a sine wave, IRMS is equal to Im by root 2. So Im by root 2. What is Im? It is 5. So 5 by root 2. This is IRMS value. Similarly, for VRMS, Vm by root 2. What is Vm? 15. So 15 by root 2. So active power is equal to I square R. So I is 5 by root 2 the whole square into R we have already found. So you will get this. You can use this formula, or you can use this formula also, VI cos phi. So V is VRMS value into IRMS value into cos angle phi. So that is equal to same value you will get. Always remember to write the units for power, because active power have watts as unit. Reactive power and apparent power unit is different. So next we will find reactive power is given by I square XL. So same thing, instead of R you multiply by XL, you will get the 18.75 var, that is volt ampere reactive. Or you can use this formula VI sin phi. Next we will find apparent power. So what is the formula? I square into Z. Z is 3 ohms. So you will get this one, or apparent power S is equal to V into I. So here the unit is volt ampere. So you can check your answer. Root of P square plus Q square will give you yes. So if you like the material, do subscribe to Read Electric Vehicle channel. These are the references I have used. Thank you.